And let's consider this past question. It is saying that a right angle triangle of side AB 30 centimeters and BC 40 centimeters is made to rotate its hypotenuse. So AC is the hypotenuse, so as to generate a double cone. We should calculate correct to three significant figures: the base radius, the height of each of the cone, the volume of the double cone, the total surface area of the solid form. We should take pi to be 3.142. So first, let's consider a sketch. We are being told that a right angle triangle. So let's consider this diagram. It should be right angle triangle. So let's suppose that this is 90 degrees. Now, there's a hypotenuse. There's a hypotenuse. So we are drawing the same thing because it was made to rotate. So this is also 90. Now, let's come out from with a line that is from this side to the other right angle triangle. So clearly, this is one cone, this is also another cone. Or we can say that this one cone, this is also another cone. Okay, let's suppose that this one is our H1, and then know that this will also meet at right angle. And this, let's consider this as our H2. Now this is our R1, this is our R2. Now let's label it. You can say A, B, C, and then this B prime. Now from the question, we are being told AB is 30, AB 30 centimeters, BC 40, BC 40 centimeters. So this is 30 centimeters and this is 40 centimeters. Now the first one says we should find the base radius. We want to find the R. We want to find R. But know that R1 and R2 are the same. The radius are the same. So let's just indicate it by R. Now how can you get R? You can see that we have two triangles. We have one triangle, we have another triangle. And because they are congruent, the areas are the same. So you can say that we consider area of ABC, another area of AB prime C. We equate it and we can find the radius. Now, can we find AC? Yes, we can find AC by applying the Pythagoras Theorem. What do we know? We know that AC square is equal to AB, that is AB square plus BC square. Now what is AC? We don't know. Oh, you know AB, that is 30 square. You know BC, that is 40 square. Now AC square will go and change to become square root. So we have 30 square plus 40 square. And from here, when we use the calculator, this would give us, that is 50 centimeters. So that is our AC. Now from here, what do we know? This is a right angle triangle, this is another right angle triangle. So you can equate the areas and then we'll be able to find the radius. Now from here, we can say that now area of ABC, so here we can say area of ABC triangle ABC, this is the same as the area of triangle AB prime C. Now what is the area of triangle ABC? We know that area of a triangle is half times base times height. So clearly half. Now, what is the base? Let's use AC as the base, which is 50 times the height. The height is radius, which is the R. And this must be equal to area of that. Now, this is a triangle, so AB and then BC. So from here, we can say that half times the base. Okay, let's use AB as the base, so times 30, and then the height, let's use BC, that is 40. 2 will go here, 1, 2 will go here, that is 20. Now, 2 will go into 50, that is 25, so we have 25R. 30 times 20, this will give us 600. Therefore, our R will be 600 all over 25, and this is 24 centimeters. These are R. Or, let's suppose that the angle over here is X. Let's suppose the angle over here is X. Now, we have a right angle triangle. Let's suppose that this one is O. That is BOC. Now, what is sine X? Clearly, you know that this side, this is 90. This side is also 90. And this side is also 90. Sine X, we know that opposite over hypotenuse. So we know sine X. Opposite is our R, all over our hypotenuse, which is 40. And the same sine X, when you consider that is ABC, sine X, what can we see? That is opposite 30 over AC, 50. And this one is the same as 30 over 50. So from here we can say R equal to 30 over 50 times 40. What can we see here? This 0 is cancelling out that 0. 5 will go into itself 1, 5 will go into 40. That is 8 times. What is 3 times 8? And this is giving us 24. That's another method how we'll be able to find our radius. Now, so the first one says we should find the radius. Now the second one says we should find the height of each cone. So clearly we can find H1, and then we can also find H2. Now with this, we know R to be 24. So we can consider this right angle triangle. That is AOB1 to find our H1. And then the second one we can consider that is OCB, also to find the second one. So let's consider the first one so that we can find the height. So let's say H1, our R is 24, this is 90 degrees, and then this is 30. Now from here, using Pythagoras Theorem, what do we know? H1 square plus 24 square equal to 30 square. So H1 square, that is 30 square minus 24 square. Now the square will change to square root. H1 equal to 30 square minus 24 square. Square root of that. And H1, when we use the calculator, now this one will give us, that is 18 centimeters. Let's also see the second one. Now the second one, we can consider the second right angle triangle. This is H2. Now the hypotenuse, that is, this one is 40, the radius is 24. So applying the Pythagoras theorem, what can we see? H2 square plus 24 square equal to 40 square. Now H2 square equal to 40 square minus 24 square. H2 equal to square root, we have 40 square minus 24 square. Now 40 square minus 24 square, this when you use the calculator, it is giving us 32 centimeters. So the second one, we should find the height of each cone. So this is the second one, height of each cone. Now the next one says you should find the volume of the double cone. Now, for us to find the volume of the double cone, now, what's the formula for finding volume? Volume is giving us 1/3 times the base area times the height. Now, the height becomes H1 plus H2. Now, the C says you should find the volume. So, volume, you know, volume 1/3 base area times the height. Now, 1/3, but then our pi is giving us 3.142. Don't forget. And then what is the radius? The radius is the same thing, so we have 24 square. Now, the height is the same as AC, which is H1 plus H2, which is 50. Now, when we punch this on the calculator, we are getting our volume to be equal to, that is 30163.2. But then the question says to trace significant figures. Now this is a first significant figure. This is a second significant figure. This is a third significant figure. So clearly, because this is a third, this is, we change this to 2. So you have 3, 0, 2, 0, 0 centimeter cube. That is the 3 significant figure. Now what is the D saying? The D is saying that we should find the total surface area of the solid. So that one would be the surface area of the first one plus the surface area of the second one. So that is our total surface area. Now, clearly the base wouldn't be there, so we have pi r L1 plus pi r L2. Now, clearly pi r is the same thing, so we have pi r, factorize it out, L1 plus L2. What is pi? 3.142. Radius is 24. Now our L1, that is 30 and then 40. So we have 30 plus 40. So we have 3.142 times 24 times 70. That is 30 plus 40, 70. And when we use the calculator, we are getting 5278.56. Now the question is, it should be to 3 significant figure. This is the first significant, second, and then third. This is 8, so to change this. So you have 5, 2, 7. So this first, second, third. So this will be 8. So 80 centimeter square. Now this is a composite shape. We have a cone and then a cylinder. This is NOVDEC 2003, question number 12. A very nice question. It says that a solid metal cuboid of length 11 centimeters, breadth 4 centimeters, and height 3 centimeters is melted to form another solid consisting of a cone and a cylinder. So this is the cylinder, and then this is the cone, as shown in the diagram above. It says that the height of the cone is 4 times that of the cylinder. So the height of the cone, that is 4x, and the height of the cylinder is x. This is all to scale. It is saying that, and the radius is 3 centimeters, assuming that no material was lost. Now, we have a cuboid, and this cuboid was melted to form the cone and then the cylinder. No material was lost. In this case, we can see that the volume of the cuboid, which was used to form the cone and the cylinder, will be equal to what? The volume of the cone plus the cylinder. So you say that volume of the cuboid, this is equal to volume of the cone plus volume of the cylinder. What's the volume of the cuboid? The volume of the cuboid is given as the length times the breadth times the height. What's the volume of the cone? That is 1/3 base area times the height. Let's say h1. Now what's the volume of the cylinder? That is base area times the height. Let's say h2, because the heights are not the same. That's why I'm using different one. Now what's the length? The length is given as 11. The breadth, that is 4. And then the height is, that is 3. Now 1/3. What is our pi? 22/7. And then what is the radius? The radius is 3. So radius, that is 3 square. And then what is the height of the cone? The height of the cone is 4x. Now pi, that's 22/7. The radius is 3, so you have 3 square. And then the height, that is x. Clearly, let's see. So 11 times 4 times 3, this is 132. Now this 1/3, we have 3 square, so 1 of the 3 will cancel 3 here. So you have 22 times 3, and this will give us, that is 66. 66 times 4, this is 264 all over 7. Don't forget we have x. Then we have 9 times 20, this is 198 all over 7x. From here, what is the LCM? LCM is 7. So you have 132 times 7, equal to 7 times 264 all over 7x plus 7 times 198 over 7x. This 7 is cancelling out that 7. This 7 is cancelling out this 7. Now, what is 132 times 7? And this is 924. We have 264x plus 198x. We have 924. Now, what is 264 plus 198? This is giving us 462x. We want to find x. What do? We divide by what is multiplying the x. 924 over 462 equal to 462 over 462x. This cancelling out that. And this will go into this. That is 2 times. So we have our x to be 2. That's our x. But then the first question says to find the height of the cone, A. Now, height of the cone. We know height of the cone. This is giving us 4x. And then our x is 2. So we have 4 times 2. And this will give us 8 centimeters. Now, the B says that we should find, correct to 2 decimal places, the volume of the cylinder. Volume of the cylinder. Now, volume is, that is cross-sectional area times height. Now, what is pi? Pi is 22 over 7. What's the radius? That is 3 square. And then what is the height? The height of the cylinder. The height of the cylinder is x. So that is 2. And when we punch this on the calculator, this will give us, that is 56.571. But then the question is saying that, says that we should find, says join together. So this, let's leave it in 2 decimal places. Let's leave it in 2 decimal places. So this is 56.57. Now, the C is saying that we should find the total surface area of the new solid formed. To find the total surface area of the new solid formed. Now, the solid form consists of a cone and a cylinder. A cone and a cylinder. But note that here it is going to be a hollow cone because it is joined together. So we are going to have a hollow cone over here. Clearly, the area, the total surface area of this new solid form will be what? The curved surface area of the cone plus the curved surface area of the cylinder plus the circular part of the base. Remember, it is going to be open. So with this, our TSA will be pi RL plus pi R squared plus 2 pi R H. Why? Because one end open, and if one end is open, we are going to get pi, we are not going to get 2 pi R squared, but then we are going to get what? Pi R squared, because one end is opened. That is from the cylinder side. And then the cone to the surface area will be pi RL. No base part. No base part. Now, from here, do we know our L? We don't know our L. So we have to find the L. Let's consider the cone. Now, with the cone, we know the radius of the cone. That is 3. The slant height, this is a slant height. The height of the cone, we had it to be 8. So clearly, from here, we can consider the right angle triangle. This 90, this L, this 8, this 3 centimeters. So from Pythagoras Theorem, we can say L square equal to 8 square plus 3 square. Square will not change to what? Square root. So we have square root 8 square plus 3 square. That's our L. And clearly, using the calculator, we have 8.544 centimeters. Therefore, our total surface area, pi RL, pi, 22 over 7. Radius is 3. The L is 8.544. Plus pi R squared, pi, 22 over 7. R is 3 squared. Then plus 2 pi R each. So 2 pi, 22 over 7, R 3. What is the height of the cylinder? Which is what? 2. Now that's what you have. When you punch this on the calculator, you have 146.5577. Let's change this to 2 decimal place. So this is 146.562 decimal place. This time we change this to 6. Because it's area, we have centimeter square. Now let's consider this composite shape. We have a cone and then a cylinder. It says that the diagram shows a hat made of a conical roof and a cylindrical wall. So this is a conical roof and then the cylindrical wall. It says that the height of the roof is 2 meters. So you can see 2 meters. And its base radius is 3.5. Now, be very careful here. The base radius of the cone is 3.5. But then the base radius of the cylinder is not known. It says that the cylindrical wall has a height of 2.5 meters. 2.5 meters. And a base area of 28.26 meters square. Clearly, we can find the radius from the base area, because you know pi r square will be equal to what? The base area, which is what? A circle. And from that we can find the radius. It says calculate correct to 3 figures, that is the slant height of the cone. So first one, we want to find the slant height of the cone. So we have the cone. Perpendicular height to the center. Now this is 2 meters, this is 3.5. Want to find the slant height. So let's see this right angle triangle. Now this is 3.5. This is 2, and then this is L. So from the right angle triangle, that is from Pythagoras Theorem, what can we see? L square equal to 2 square plus 3.5 square. So the square will not change to a square root. You have square root of 2 square plus 3.5 square. And when we use the calculator, we are going to get, that is 4.0311. But then the question says to 3 significant figures. This is the first significant, second and third. So this is 4.03 meters. That's the first one. That's AI. Now, the II says that the surface area of the conical roof. Now, when you look at the conical roof, clearly, because the cylinder is joined to, there's a roof to it, clearly this is going to be what? A hollow cone. A hollow cone. And the surface area of the hollow cone is the same as what? The curved surface area, which is pi r L. So the surface area, this is pi r L. Now what is the pi? We're given the pi to be 3.14. What's the radius? The radius is 3.5. And then what is the slant height? That is 4.0311. Now, when you punch this on the calculator, we are getting 44.301, and then to 3 significant figure, that is 44.3 meters. Now, the third one says that the external surface area of the wall. The external surface area of the wall. Now, this is the wall, and here we can see the inside part. But it's not talking about the inside part. It is talking about only the external surface of the area. Clearly, this wall is cylindrical, and the external surface area, that's the curved surface area of the cylinder, which is giving us what? 2 pi r h. So the third one, external surface area, that is 2 pi r h. Now we know the height of the cylinder to be 2.5. We know pi 3.14, but we don't know the radius. But we have been given the base area of the cylinder. Now, base area of the cylinder, and this is equal to, that is, we're given as 28.26 28.26. But this is a circle. So what do we know? We know that pi r squared, that is 28.26. We can find the radius from here. Now what is our pi? The pi is 3.14. R squared to equal 28.26. So we want to find r. We divide both sides by what is multiplied by the r. So we have 28.26 all over 3.14. Our r squared, when you point this on the calculator, you get 9. So r will be square root of 9. The square will change to square root. And this r will be 3 meters. Or you know, r squared equal to 9. R squared will be equal to 3 squared. So r equal to 3. The exponents are the same. So what do? We equate the basis, which is 3. Therefore, the external surface area, you know, 2 pi RH. And 2, what is the pi? The pi, that's 3.14. What's the radius? The radius, we have 3. And then what is the height? The height is 2.5. Now, let's put 2 times 3, that's 6. Let's punch times 3.14 times 2.5. Now, when we punch this on the calculator, this is giving us 47.1 meters. So that's the external surface area of the wall. Now let's see the B part. Now the B part is saying that if the cost of painting a square meter of surface is 450 cedis, we should calculate the total cost of painting the outer area of the wall and the roof of the hut. Now we want to paint this, and we want to paint the external, that is the outer area of the wall. The outer area of the wall is what we have found, which is the external part, and then the and also the outer area and the roof of the hut, which is the surface area of the cone too that we have found. So clearly, that part, outer area of the wall and the roof. Now, what is the outer area of the wall? The outer area of the wall, we had to be 47.1. And then the roof, what did we get? We had, that is 44.3. Now, when we add these two, we are getting 91.4 meter square. Now from the question said that the cost of painting a square meter is, so 1 square meter, this is giving us, that is 450 cedis. What about if you have 91.4 square meter? What will be the cost? If 1 is 450, what do you think will be 91.4? That will be more. So you see, if more, let's divide. So we have our x to be 91.4 over 1 times 450. And this would give us, that is 41130. Clearly, the cost, the total cost of painting the wall, don't forget to add your units. So we have 41130.00. Because it's currency, we have to end with the 0.02 decimal places.